expressions. We'll look at assignment operators and the various ways we can do assignments in C. We'll look at some unary operators, and finally we'll wrap it up with a discussion of logical expressions in C. In terms of arithmetic expressions, we have all the usual culprits in the C programming language. So we've got the plus operator, the subtraction operator, multiplication, and division. And these are binary operations, of course. They require two operands, two variables, or two values. And if you've learned another language that has a C pedigree, you'll be very familiar with the syntax for expressions in C. Now the association on these binary operators, or the processing order, is from left to right as they appear in the expression, but we do have different precedents for different operators. So plus and minus have the same precedence, so if they're mixed in a single expression, evaluation will proceed from left to right. Multiplication and division, on the other hand, though they have the same precedence, they are of higher precedence than the plus and minus operator. That means if there are multiplications and divisions mixed into the expression, that those will get evaluated first. So basically all the things you learned about these expressions in junior high math, or maybe even grade school, apply here when we're writing these expressions in C. And finally, we also have modifiers. We have a plus for positive or a minus for negation. And these are highest precedence. So these will actually get evaluated before those binary plus, minus, multiplication, or division. So here are some examples. So let's assume we have a variable x defined as a double, and we've assigned it to 2.0 initially, and we also define a variable y with a value of 5.0, and we've defined a variable z but left it undefined. So in this first expression, we have z equals x plus y. So it's basically going to do the simple addition, giving us the value of 7.0 and z. In this next example, we're subtracting x from y, which leaves us a value of 3.0 in z. And in this expression here, we're doing a simple multiplication, 2.0 times 5, x times y, which gives us 10. And finally, a division where we divide y, which is 5.0, by x, which is 2.0, giving us 2.5. Quite straightforward so far. Here's some examples that help us understand this notion of precedence. So I've got a double a equals 10.0, a variable b equal 5.0, a variable c equal 2.0, and then a variable z, which I've left undefined. So in this first expression, I have z equals a plus b divided by c. And so we know from the precedence orders that we just talked about that that division has to happen first, and after that the addition. So we're going to have 5.0 divided by 2, which yields a 2.5, which then gets added to 10, which gives us a 12.5. So the printf statement, which appears right under the expression, is actually going to print out 12.5. In the next example, we have z equals a plus b, but notice we've put parentheses around the a plus b here. What this does is it forces, or it instructs the compiler, we want to have a added to b before doing the division by c. So in this case, we have a plus b, which is going to give us 15.0, divided by c, which should give us 7.5. So in the printf, that statement that follows the expression, we should see it outputting the value 7.5. So I've taken all of the operators in the C language and put them in a table here. Now many of these we haven't talked about yet, but we will. But you can keep this as a handy reference in terms of precedence. And in this chart, precedence is increasing from highest to lowest. Let's talk briefly about assignment operators. We've already seen a simple assignment operator. such as this, the basic assignment. So here I have I equals I plus 1, and this simply computes the value of I plus 1 and then stores that value in the variable I. We can also do assignment operators like this. So I have I plus equal 1, and this is equivalent to the statement I equals I plus 1, or I have the statement I times equal 2, which is equivalent to I equals I times 2. And I can do that with all my binary operators. I can put the binary operator followed by an equal, and the same pattern applies. We also have a number of unary operators in the C language. In this example, I'm showing you the increment and decrement unary operator. So in this example, I have I equals 2, j equals 3, and m equals 7, and I've defined the variable k but left it uninitialized. In the first statement, k equals plus plus I plus j. The plus plus I is what we call a pre-increment here. Because the plus plus operator appears before the variable I is going to get pre-incremented. It's going to get incremented before it's used in the broader expression in which it appears here. So in this case, the I is 2, so it's going to get 3, which we're going to add to j, giving us a final value of 6 in the variable k. In the second example, I have what's called a post-decrement. The minus minus appears after the variable m. So what's going to happen here is the addition is going to happen first, so n plus j, or 3 plus 7, giving us 10. And afterwards, we do the decrement. So m will have 6 after this expression is evaluated, but the value of k will be 10. Finally, in C, we also have logical expressions, and in C, any variable can be interpreted in a logical sense. So this is in addition to its normal numeric interpretation. So a variable in a logic sense is either going to be true or false. And so it's a Boolean interpretation, and the variable is going to be false if its value is 0, and it's going to be assumed true if it holds any non-zero value. So here's some examples. The variable int x holds a value 7, so if this were to appear where a logical expression is expected, it would appear or be evaluated as a true. In the second one, I have double z equals 0.0001. Once again, that's non-zero, so if this variable were used where a logical expression is expected, it would assume the value of true. In the third example, I have a car ABC equals hex 0. So the 0x preamble on that, or prefix on that literal there means it's hex 0. And that's going to evaluate to false because it's 0. In the next example, I have car x equals the literal character A, and that is also non-zero, so that will get evaluated as true. And then finally, I have a float b equals 0.0. That is 0, so if it was used in a logical expression, it would be false. Now, we'll see later on when we talk about branching and looping how logical expressions are used. But for right now, let's take a look at a hands-on example to demonstrate some of the concepts we've learned in this lesson. So let's write a simple program to demonstrate some of these concepts we've learned about arithmetic expressions and precedence of the various operations. So let's write a simple program called expression.c, and once again I'm going to do some printf, so I'll have my include for the standard.h here, and we'll go ahead and add a main routine, and it takes no arguments. And let's add some variables. We'll have an integer a, which we'll set to 100. We'll have an integer b, which we'll set to 2. And we'll have an integer c, which we'll set to 25. And an integer d, we'll set to 4. And finally, a result that we'll leave uninitialized. Now those are not very good variable names in a real program. You'd want to have more descriptive variable names, but just for demonstration purposes, it'll suffice for now. So we can do simple subtraction. So if we say result equals a minus b, it's simply going to take the value of a and subtract from it b. So we could print this out as follows. We'll put result here, and we can similarly do multiplication, and let's do a division. And let's do one more just to look at the precedence. And we'll do something here. We'll say a plus b times c. So we're interested in seeing how precedence works here. And so in this case, we're expecting the a plus, or I'm sorry, the b times c to be calculated first, and then that value added to a. So b times c is going to be 50, so we're expecting that to print out the result 150. So let's do one more calculation. Let's say, so one of the things we can do is we can just have an expression and feed it right to printf. So we could do this type of an expression, and then we'll put the expression right here. And finally, we need to return 0 from the main function. So let's compile this, and if we run it, okay, sure enough, the a plus b times c evaluated correctly, as did the a times b plus the c times d. So in that last one, the multiplication happens first from left to right, then the addition.